आपके साथ रिकॉर्डिंग का ऑप्शन आ रही है?
Yes, sir.
So today let's start the today class. In today class we will study the efficiency of transmission, that how we will calculate the transmission efficiency of optical fibers or any optical fiber system. And here we will study some sub-blocks. If we apply the input to one sub-block and it give output to another sub-block and so on, and the last we will take output from the last sub-block. So what will be the effect of efficiency? So here we will study the efficiency of sub-blocks. In the lab session, we will design the sub-blocks. That's how we will design the sub-blocks in FT system software. So consider this is the an optical fiber. The signal which is entered to the input is input to this optical fiber whose power is P1 watts. In the output taken from this optical fiber is P2 watt. We will apply the signal at input and we will take the output from the outside. So if we apply the signal at this point, so it will be some P watts. So the P1 watts is the power applied to the starting position of the optical fiber. And when the signal travel in this optical fiber and will reach to the end point, so the signal received at that point has power P2 watt. So what is the efficiency? The efficiency of this transmission will be the ratio of the output power to the input power. So the equation 1 show the P2 divided by P1 is the efficiency of transmission line. But we calculate the value of this in dB because its value is small, so we want to calculate the value in dB. What it mean by dB? dB mean decibel. So when you want to convert the value to dB, we will apply 10 log 10 P2 divided by P1. So this is the value of the efficiency in dB. P2 by P1 is the efficiency of transmission line. When you multiply the 10 log 10 of 10, so this will convert the value into dB. B mean bell and dB mean decibel. Bell is the large unit and decibel is the smaller unit, and 10 decibel become equal to 1 bell. So when we, this is the formula that how you will convert the efficiency of transmission line into dB. 10 log 10 of P2 by P1. So when we apply the 10 log of equation number 1, we will get the equation number 10. Either you can see that it is like this. This is the efficiency of transmission line. So when we multiply 10 log of 10 here and 10 log of 10 here, so what is this? 10 log of 10 of efficiency mean dB value of efficiency, and this will be equal to 10 log 10 of P2 by P1. अभी समझ आ रही इसकी? That this is the efficiency of transmission is equal to P2 by P1. So taking log 10 both sides. So log 10 of efficiency is equal to log 10 of P2 by P1. Multiply 10 both sides. So 10 log 10 of efficiency is equal to 10 log 10 P2 by P1. And 10 log 10 of efficiency means dB value. And dB value is equal to 10 log 10 of P2 by P1. This is the efficiency of the transmission line. But you see that when the signal enter to the transmission line, so its power is P1, and when it leave the transmission line, optical fiber, so it means its power will be P2. So as it travel from this optical fiber, it means there will be some attenuation in the signal take place. So that is why the power P2 will be less than P1. So it means that the P2 will be less than P1. It means that the attenuation will be take place. The attenuation of the signal will be take place. In this case, when you calculate the value of dB value of efficiency, it will give the negative value. It means this is the lazy system. By the lazy system, we mean that there is loss in the signal, loss in the power, and attenuation of the signal will be take place. But if the P2 is greater than P1, if P2 is greater than P1, so in this case, the dB value will become positive, and we say that this is the gain of the system. For example, you want to amplify the signal. You have an optical signal, you want to amplify this, so you will use the optical amplifier. So in the case of optical amplifier, the input signal will be P1 and the output signal will be P2, but the P2 will be greater than P1 as you want to amplify the signal. So in this case, the dB value will be positive, and this is the gain of this optical system. So this is the difference between the gain and efficiency. That gain is also the P2 by P1, and efficiency also P2 by P1. But here the P2 must be less than P1. In the case of gain, the P2 must be greater than P1. So this is called the efficiency, and this is gain. So suppose this is the equation 2, and this equation 2 show the dB value of efficiency for the transmission line and for the optical fiber or any system, any transmission system you consider this. So as we study the optical fiber communication, so we say that this is the efficiency of the optical system or any.
एक्सक्यूज मी सर
जी
सर ये आपने जो फार्मूला बताया है ये सारे ट्रांसमिशन लाइन के लिए या सिर्फ ऑप्टिकल फाइबर के लिए हम यूज करते हैं?
ये दूसरे के लिए भी है, ठीक है, क्योंकि इधर भी ट्रांसमिशन होते हैं उधर भी ट्रांसमिशन होते हैं, तो इस तरीके से हम इसको कर सकते हैं, लेकिन इसको हम इधर ऑप्टिकल फाइबर पॉइंट ऑफ व्यू से बता देते हैं, ठीक है.
यस सर.
So if you want to calculate the power, either input power, either output power, G, and if you have if you have this equation, consider if you have the equation 2 and you want to calculate power, output power, either the ratio of the power P2 by P1. So how you will calculate? Consider Also Chukun ke das schön. Aber wenn es da ist. So consider the DB is 10 lakh 10 of P2 by P1. This is our equation 2. When we divide both sides on 10, so it will be divided by 10. So it will become cancel. It means that dB by 10 is equal to log 10 of P2 by P1. So how you will get P2 by P1? Anyone? P2 by P1 हम इसे कैसे लेंगे? ये log 10 को ख़त्म करना चाहते हैं, तो कैसे क्या करेंगे इसके लिए? शाबाश।
सर इसमें हम P2 और P1 फाइंड करना चाहते हैं।
We want to calculate P2 by P1. So इधर वे log 10 है, तो इस log 10 को ख़त्म करना होगा, ये इससे शिफ्ट करना होगा इधर, तो कैसे शिफ्ट करेंगे?
Anti-lag वो officer द्वारा set
We will take anti-lag both sides. So what is mean by anti-lag? So when we multiply anti-lag here, and multiply the anti-lag here,